continue along the lines of our discussion on cloud automation. So if you remember, in the last class we had started our discussion on learning about a service that was known as CloudFormation, right? So in a way it was also known as infrastructure as code, right? So all that we have been doing up until now was manually kind of provisioning all the resources. So CloudFormation eventually gave us the understanding that you can deploy those services by writing it as a code, either in the form of a YAML file or in the form of a JSON file, right? So what we're going to do today is basically, first of all, try to understand what this Elastic BeanStalk service is all about. In short, what it helps us is to kind of automate the process of web application deployment, right? So all of the resources that is associated with a web application deployment, which can be designed on various platforms. So if we use Elastic BeanStalk, it kind of creates that environment for us and allows us to kind of focus more on the functionality of the application rather than setup of the application, management of the infrastructure that is necessary to kind of deploy those applications and stuff like that. And after that, the second thing that we're going to cover today is basically what is known as Amazon DevOps, right? It's mostly with respect to the functionalities that developers generally tend to use. That is writing code, committing codes, testing it, building it, deploying it, and all those operations. So using Amazon, you can automate that whole process, whether you're working for a company or you are kind of oversighting or providing oversight for a project as a project lead and kind of taking care of multiple developers under your wing. So this can be done by using what is known as Amazon Code Pipeline. That is also a service, and there are associated services with the code pipeline that can be used for the process of automation. So as far as software engineering is concerned, this concept is known as continuous integration and continuous delivery, okay? Or in short, it is known as CI/CD. So we are going to see how CI/CD can be performed using the various AWS web services that we have, okay? And then finally, look at another aspect of DevOps that is known as CodeStar, right? It slightly differs a little bit from the code pipeline. So once we understand what the code pipeline does and helps us to achieve, then we can further appreciate the requirement for CodeStar as such, okay? So once we finish all of this, we will essentially kind of cover everything that is there to understand as far as automation is concerned for the infrastructure, and automation is concerned for application development. If you're working as a developer, if you're working as a software engineer, and you're using Amazon tools, and how that goes. Okay. So first and foremost, Elastic BeanStalk. So it's basically a platform as a service. Okay. If you want to express or kind of explain it to somebody with as little as words as you require, it starts with platform as a service. And you all understand what platform as a service is, right? We don't have to explain that. So that kind of conveys a lot of information. So essentially, when you are developing an application, if you think in terms of kind of like writing or developing a web application on your local machines, right? You have to get the IDEs, you have to set up the different kind of third-party softwares that is required, for example, Git and things like that. You have to install the extensions for the type of technology that you're going to be using to develop your application, whether it be in Python, JavaScript, whatever it is, right? You have to install all of that, right? So essentially, when you use the Elastic BeanStalk, right, it gives you the platform. It takes care of the scalability. It takes care of things like auto-scaling groups, load balancers, and all those essentially things that is required to make your application highly available, right? So fault tolerance is the name of the game, or resiliency or availability is the name of the game, and that's why we essentially use cloud services. So EBS, not the block storage, but the BeanStalk, essentially provides us with that platform. So you can focus on just writing the code using the technology that you are using, okay? So the available platforms that we currently have, or Amazon currently supports, is Java, .NET, which is Microsoft, PHP is there, Node.js, Python, Ruby, Go, and Docker. Okay, Docker is basically the self-contained environment, which is kind of independent of any type of operating system, right? Although even these things are kind of to an extent supported by different operating systems as well, but Docker, how it differs from the other platforms is it's mostly self-contained, You can put everything within that Docker, and you can essentially deploy that Docker as a sandbox environment on any platform. Okay, and the service that is supported is Apache, NGINX, Passenger, and IIS. IIS being the Windows service, hosting the Windows service if you try to set up an FTP using just Windows OS. Okay, so how do you do it? Well, you essentially either use the sample code that is provided by Amazon when you're launching the BeanStalk, or you can have your own code. You can have your own boiler template for whatever application that you're developing, and you can upload that code. Okay, and EBS will essentially handle the deployment, so that includes launching EC2 instances. If it requires any kind of RDS integration, you can even specify that. That is, if you want to integrate that with your database and stuff like that. Okay, so what it costs you? Well, only to store and run your applications. Just like CloudFormation, there is no additional cost to use the service itself, but any kind of resources that you deploy or you use, the basic cost model that is associated with it, like for example, if you are hosting a server, it has to be hosted on an instance, right? So what will cost you is basically what the size of that instance is, the architecture of the instance, those kind of things will essentially cost you. If you associate an RDS instance with this particular application, then that is, sorry. So those are the kind of charges that will be like given to your account if you are essentially using BeanStalk. Okay, so you can go over the advantages. The use cases are available in the documentations. I'm not going to read line by line, and well, and then these are some of the customers. Some of you might be knowing Zillow. Heard of that? Maybe. Eventually, the pain will come. You know, I can rant about that a lot, but still. Did you hear that Zillow was trying to kind of buy off the market to increase the prices? Nobody knew if that was a conspiracy theory. It has been debunked, but initially it was quite an exciting theory, believe it or not. It's just the thing, like when you're below 18, right, taxes is like a myth. And then you join your workforce, and then here it comes again in about, 2 weeks, 3 weeks of time. So Zillow will also come soon. For some sooner, for some eventually. Okay, so you can look at the use cases. So what the process is overall, what EBS does is you create your application, and you can do this locally, right? And then you want to upload the version of your code to begin with, and that will be launched into an environment from EBS. You don't have to worry about anything. Okay, so any instance that is required, whatever is happening, the EBS will take care of that. Okay, and then all you have to do is not even manage it, but you can monitor it. But as you have learned that using the notification service, which is SNS, right, you can automate the process of notification and management as well. So it can alert you if anything abnormal happens, or if you are trying to look out for any particular event like crashes and things like that, right? And anytime you want to change your code, you can re-upload the code, and that will deploy a new version, okay, by giving it a particular label. So it's very simple as far as EBS itself is concerned. Okay, so go ahead, log in, and we'll try to launch a Node.js application. You can launch any application that you want, but for this exercise, I'm going to show you with Node.js. Okay, kind of coming fresh from my last semester. So, all right. So another thing is that even security groups, to a certain degree, when you are configuring these environments, you don't have to worry about it. It will take care of it. So remember, we added security rules for port 80, right, which was Apache. So depending on the server that you're using, the type of protocol, you also added RDS. So if you add an RDS here, eventually in your pipeline, then it will configure the security group for you. You don't have to worry about it, right? So your main focus will be to develop your application, which is what you should be doing. Okay, essentially. So we're going to look for a service known as Elastic BeanStalk. Okay, so once you come there, essentially this is the fresh canvas that you'll be looking at. All right. So the first thing that you want to do is to just hit Create Application. I'm going to terminate this just for a second. I want to move away from North Virginia. Okay, so create a new environment. Okay, this is the interface that you will be looking at when you're working for the second time. If you were in that environment first time, right, you wouldn't get this option, right? But it's the same thing at the end of the day. Because if you just noticed, a few moments back when I was in North Virginia, right, it asked me for the name of the application directly. But here it's asking me whether I'm doing a back-end Elastic BeanStalk application or whether I'm trying to deploy a front-end, a web server environment. Okay, so that's another thing that you have to keep in mind, that you can run your time-consuming batch processing jobs, which is probably either going to do some market survey or things like that on the back end. It's not, exposed to the client. You have that option. So I'll go forward, and this is probably what you must be seeing, essentially. So give it an application name. I can call it test web app EBS, something like this. All right. Remember, again, keep up telling you this. We are not doing this. It's an optional thing, but please make sure that you give tags when you're working in a professional environment. Okay, it's very important to organize. So here you have the environment name. The environment name kind of just populates from the application name itself, but the rest of the stuff you leave blank. You probably won't be seeing these options for the first time usage that you're doing, but you can essentially, if you have a domain. Okay, everybody understands the concept of a domain, right, when you're launching a web server. So you can put that domain here, and then you can see if that is available. All right. In addition to that, you have different platforms. It is completely managed, and that is essentially what you want. Okay. You don't want to be responsible for managing as well, because that will kind of deviate your attention from the development process. Okay. So this is what you should be probably seeing right now, the platform itself. Now, if you go for the platform, as we were mentioning, a lot of different variety of options are there, starting from Glassfish. Some of you might have used Glassfish. Has anybody used Glassfish before? No? What was that other IDE back when Java was still being used? So other than Eclipse, do anybody remember there was another IDE which was used? Say that again? NetBeans. Yeah, so NetBeans by default had supported Glassfish. Okay, where Eclipse had the Apache option. NetBeans generally used to use Glassfish, right? So people who were, programming is always a hip culture. Some people have this following over a particular technology, and some other people have the other technology. But you get the idea. So go ahead and select Node.js. Are people familiar with Node.js here? Yes, no? Little bit? Just the name? That won't help. Okay, how about JavaScript? JavaScript, people just have an understanding? Yes? What about PHP? Okay, web server. Web programming is important, okay? So anyways, we're going to select Node.js. Just to give you a quick idea of what Node.js is, so you understand what is happening and how Node.js works, okay? Node.js, okay, is a runtime environment. It is not a framework. So that is a little bit different from your understanding, so you have to understand this first. JavaScript, when it was developed as a tool to modify the document object model of HTML, right? The site that HTML creates, it can be represented as a tree data structure, okay? And essentially that tree data structure for website purposes was referred to as the document object model, right? So your website is basically a collection of document, and every element within that document can be represented as an object, which has a hierarchical structure. That is what HTML essentially is, right? So that is where JavaScript was essentially designed, to play around with that, to give it some animations, some modifications, some interactivity, okay? But the problem was JavaScript back then, prior to 2009, was essentially not a programming language, it was essentially a scripting language. And the reason behind that was because it can only be used to provide interactivity to your front-end website applications, right? So to boil it down, JavaScript was something that can essentially run on a particular browser. So the browser is a software. It has an execution engine for the scripting language, and then it provides. So everybody had their own thing going on for JavaScript interpreters, right? So Google had its own V8 engine, and then Mozilla developed the Spider Monkey, and then I think Chakra or something like that, I don't know the exact name, that was Internet Explorer / now known as Edge. and stuff like this. So what happened is, post 2009, one of the developers decided, I forgot his name, that they took that V8 engine, embedded it inside a C++ code, and created this runtime library which allowed the execution of JavaScript outside of a browser environment. Make sense? So that gave JavaScript the true programming capabilities which it previously lacked compared to other languages like Java and Python. And then grew the popularity of JavaScript as a language, which is much more versatile, post 2010, 2011, and then it started to pick heat, right? And that was Node.js, the runtime environment, okay? So then people started using JavaScript as a server-side language as well, server-side scripting language, okay? Because essentially the logic was, well, if you are predominantly using, and JavaScript for the front end was a very dominant technology, right? People mostly used JavaScript there, right? A little bit of PHP was going on here and there. Not a little bit, a lot. Little bit will be an understatement, okay? So people's logic was that, okay, if we are already doing the front end in JavaScript, jQuery, then why not kind of extend that and keep the back end to JavaScript as well, right? So when you hear Node.js web applications, Node.js is not the framework, mind you, okay? Node.js is just the runtime environment that enables the execution of JavaScript outside of the browser environment. And that's what made it more efficient, okay? So the language or the technology is still JavaScript, okay? All right? So keep that in mind. And the server-side framework, there are frameworks that can ease up the process of development, right? So the server-side framework that is used in conjunction with Node.js is known as Express. So if you are familiar with Python, you might have heard the web development framework called Django. You might have heard this name. And then there is a lighter version of Django, which is Flask, right? So these are Python. So if there is a web server development framework for JavaScript, that is Express, which is ran inside as a module of Node.js. So like Node.js has many different libraries, it is actually called modules within the technology itself, right? So in the absence of a framework, you can still write the code for a web server, right? And that is what Node.js servers are. That is, it does not use the abstraction of a framework, but it writes everything down. Okay? So when we are choosing this Node.js, that's what essentially we are doing. We are developing a server which is written in JavaScript. All right? So you don't have to write the codes, and then there are platform different branches out there. You can choose the different versions. It's always good to use the most up-to-date version, right? Don't use deprecated stuff. All right? So now here, coming to the application code, any questions at this point? Okay. So the application code, you can either choose the sample application that is provided by Amazon for the hello world purposes, right? So it will just launch the whole thing, and then you just have to access the code and start editing the code for your own purposes, okay? Or you can upload the code, right? You can upload the code by providing it with a version label. You can give a S3 URL if you have already uploaded the code to the S3, or you can choose a file from your local repository and you can upload that. So for the time being, for at least for this exercise, we'll just select the sample application, right? And then we will just go with configure with more options. So as you go to configure with more options, it will kind of give you the review for all of the different things that is available. So if you look at the presets it's with respect to your deployment options, right? So we are going to be sticking with free tier, but please observe the different options that are available here with respect to what kind of instances will be provisioned for your web application, right? So one of the most important things that you would be doing for a more practical deployment is to choose high availability. You need to make sure that you do not kind of launch your web application on a single instance such that if that crashes, everything is just gone there, right? So high availability is basically the option. You can even do custom configurations if you want to, but we're going to stick with free tier for the time being. Okay, you can change the options for software, for the instances that has been given for you, the capacity. If you want to do more than T2 micro, T2 small, you can change the options, and that is going to kind of change all of the information. You can change the EC2 image ID. If you want to use a different kind of distribution, you can do that. Load balancer you don't get in the free version. Okay, if you go for high availability and stuff like that, you will get a load balancer, right? The reason why we say that is you always have to remember from this point onwards, for any kind of practical deployment, you have to remember that architecture, which is with auto-scaling groups and load balancer as the front, right? Your instances is always going to lie within the ASG, and the ASG will be fronted by the ELB. So that architecture should be in your mind all the time. Now, how you spread it across the different subnets, that will kind of decide whether how much fault tolerance you have, how much availability, how much replication you're doing, and stuff like that. Okay, and then you can add new security service rules, when your key pairs, any kind of monitoring that you want to add. All right, notifications if you want to set it up. If you want to add a database here, you can set up a database. Essentially, you can add the engine. So anything that you want to go into. So if I want to do the database, I can just edit it, right? And similar to the database operations that we did, the exercises that we did in the RDS, you can choose what kind of SQL engine, that database engine you want to deploy, what is going to be your instance, and then this will be by default connected to the instance where your application will be living. Does that make sense? If you remember when we did the RDS exercises, right, when we launched a web server with WordPress enabled in it, right, we had to configure WordPress, and then we had to provide that endpoint of our RDS instance to our WordPress instance that is running on an EC2, right? So here you don't have to worry about all those things. If you just specify the fact that, hey, I need a database like this, it is going to take care of those operations, okay? So we are not going to add a database for now, for this particular exercise. So once you're done, once you're happy with everything, just hit create environment, and you can see here the different operations that will start to take place, right? You can monitor it, you can kind of look at it, see what is happening and stuff like that. Essentially, it will create an S3 bucket, put all your data in there, right? It will create an EC2 instance, then load a Node.js web application and a web application server on it, and then essentially give you the front-facing URL link to it, all right? So probably like 3 or 4 button clicks is all you need to kind of launch not just the infrastructure, but essentially the environment as well, the application environment. So that's how it automates the process of deployment of your web applications or your web service, right? So it's going to take some time. It's going to take care of everything. If you keep a notice on the different event logs that is being populated right now on your screens as well, you will notice that all the steps that you took manually when you are doing these exercises, right? We have been doing multiple web application deployment exercises, but you will see the security group allocation, the S3 bucket initialization, creating a backup, launching the instance, everything will keep on happening. Okay. The only thing, it also creates an EIP. What is an EIP? Not external. Anything E on Amazon is mostly elastic. But what is an elastic IP? Think in terms of the foundations when we were discussing in the first month, right? What was the options? If you launch anything public, it will be assigned an IP address. But what is the downside of that? It's a public IP address, but if you shut down the instance or if you terminate it, then that IP address is gone, right? So if you do elastic IP address, then essentially that elastic IP address, instead of being dynamic, it is static. Static being that even if you terminate it, that IP is still there, okay? Remember, assigning or allocating an EIP does not cost, okay? But if you allocate an EIP and your application is not in use, that is, you're not using the allocated IP address, then you will start to incur cost, okay? So remember that. All right. So we'll wait on this for a few seconds. Okay, so my instance got just deployed. Some of you, is anybody ahead of this? No? Okay. All right. All right. So once it's done, this is what you should be looking at. Okay, if you haven't got there, you will get there, don't worry, right? So you get a health status. If you have any problems, it will either show that your operation is halted, or warning, or error, or pending. These are the different kinds of prompts that you will get. And what do you do when you do hit an error? You have to debug. Essentially, you have to know what the problem is so that you can solve it. So the way to initially do it is to go from this left menu to this option for logs. So if you go to logs, and if you go to this request logs button, then you have the option to either get the full logs, or you can request the last 100 lines, the tail end of your log application. So essentially it will populate the logs, and then you can open it up and you can check all of the different operations that has happened. So here you get the info because nothing went wrong. But if something goes wrong at any point of time, you will either see warning, error, ERR, and things like that. So then you have to read these logs, and then you have to essentially, well, deal with it, like we say, right? So that is one of the options. So if you come back to your web application environment, if you are changing your application at any point of time, then you will upload it again, and then it will get deployed, right? So locally you're working on this, you're done, right? Then you can take the code and then you can upload it. But what is the problem here? Can somebody tell me, like, do you do this? This is how do you develop applications? No, right? You don't like make a change, zip it in a folder, and then come to a interface and then upload it for every other, line break that you give. This is not how you work, right? So what's missing here? Essentially a syncing application, right? Something like Git, GitHub. That's basically the next topic where we will be going towards, all right? But for now, this is what enables the deployment of applications. Yes?
Probably wrong on this, but if you're utilizing the Elastic Beanstalk for your code and whatnot, can you use something like Bazel to deploy the code and test it? Or
so there is a different service for testing and building and deployment, separate.
Okay.
And all of these can be grouped together to automate the entire process. So you don't have to, if you want to, you can manually give the checkpoints, but you can also automate it if you're sure about it. So that's basically the next thing that you run next. Okay. So that's where the upload part comes. All right. So you can look at the recent events here, and if you want to reach out to the front end of this application, then this is the link essentially. So if you go to this environment, then that would open the hello world page that has been deployed using the sample code that we just used. Okay, and the sample code is also available. None of these links are going to work, and it's going to take you back to AWS platform. But you get the idea. If you have this, you can start editing very fast, and you can start replacing all these placeholders with your stuff. That is something that we understand, and that is something that we can work with, right? So we did not work with IDEs. We did not do anything, right? We just clicked a few buttons, chose our platform, specified a sample code, and well, our application is running essentially. So in 5 minutes you can reach to this point. Okay, and then editing, probably all you have to focus on is just the code. That is essentially what we do. So if you look at the left hand side menu, you should see a go to environment option here, right? So if you go there, so this is basically your public DNS. Okay, so if you recall in the initial options that I was showing you, there was an option for DNS, right? So if you want to change this URL link, then essentially you can specify a DNS, but you have to register that with Route 53 or some other DNS service. Okay, if you don't use Route 53, which is Amazon's DNS registration service, you should be using something else, Google, whatever it is that you like, right? So then you can specify that, and this will give you a more customized URL if that is what you want, all right? Okay, so any questions here? All good? Remember, this was created in S3 bucket, by the way. The reason why I mention is once you are done with everything, you have to go through S3N, make sure that you're not using the space unless you need to use it. Okay, so if you're done, in actions, you can come down and you can terminate the environment for the very last option. Don't do it because we will need it eventually. All right, or you can do it because launching this is not going to take too much time. Right? But leave it as such. That's what my suggestion would be. So this is what Elastic Beanstalk is. It's a platform. You have to remember that thing. If somebody asks you to define Elastic Beanstalk, what it does, your first answer should be it's a platform as a service that is used to develop the environment or provide the environment and manage it for deploying either web service or back-end batch processing applications. That is time consuming in nature. That's the most simplistic definition of EBS. You don't have to memorize it, understand it. What is it? It's a PaaS. What does it do? It gives you an environment, manages the environment where you can deploy web servers or backend applications. That's it. Okay, to the point, explain what is it, what does it do. And you don't have to give any kind of memorized or clever looking answers. Clear? Okay? So, remember, this is just one of the many services that can achieve the same thing. You can launch a website on S3. You can launch a website on EC2, right? You can write an ASG and you can launch your website by providing data, user data in the launch template. Multiple ways of doing it, each has its own benefits. That's the thing. Here the management becomes much more simplistic. So we are moving more towards the part where we as a developer, we are not responsible anything as far as management is concerned. That's where we are getting at, slowly, okay? All right, so once this exercise is done, the next thing we are going to move into is basically what is known as DevOps, right? In DevOps, we're going to learn about what is known as creating a code pipeline. Does everybody from computer architecture understand the concept of pipelining? Yes? Recall, maybe? Sometime far, far away in a galaxy, we learned about it, but we were sleeping. Yes?
Pipeline is CI/CD, continuous integration, continuous development, kind of goes in the down.
Correct. So the concept of pipeline in itself comes from computer architecture. It's where when you are executing or trying to execute one of the applications, you load the immediate next application. So it goes into this pipeline and continues this operation. So there is no delay for the next applications. You don't wait for the first to finish before starting the next. So once you start that, essentially that makes it a pipeline. So if you think in terms of development, as a software engineer or as a software developer, right, essentially what you're doing, you're developing, right? And the process of development can be essentially broken down into three major steps. First, you're writing the code and stuff like that, but then you push the code to a repository, a repo, right? You commit. That's the first step, right? Second step, once you have committed, right, the next step is to build and test. You have software testers and stuff like that, quality assurance, those kind of things. So that's the major second step, that you build and you test, right? If you're building, then you're basically providing maybe some kind of external parameters, some kind of URL, whatever it is that your application needs to run, right? And then you test whether it is running or not based on whatever test cases that you have developed. And then the third is when you have tested it successfully, assured that it's working as it should, then you decide that, okay, now is the time to deploy. And the deployment will happen in some kind of environment. An environment, the one that we just learned right now, right? So now the processes, all of these processes essentially, you can think of it mutually exclusive of each other if you want it to be, right? And then you have to manually address all of these processes, right? But you don't essentially need to wait for one to finish to begin the next. You know, nobody has stopped you from rewriting your code or writing new pieces of code and then committing that because your previous piece of code is being built and tested. See what I'm saying? Right? So you want to automate this whole process and you don't want to be responsible for managing that automation. You want to provide the configuration specifications and you want to have that trust that it is being done for you, and all you do is write code. That's what your job is as a developer, right? So this whole process is essentially summed up within this software engineering concept of continuous integration and continuous delivery, or in short, that is known as CI/CD. Okay? So continuous integration is to basically create this one single main code base. When you're working in a realistic project, right, you're not the only one who is working on that entire project. There will be multiple developers working on different aspects of the project, right? And the whole goal is to make sure that you create this one single software or prototype that the user can access. All of the different units working together, right? So essentially, if you are writing a code for one of the units of the project, right, then you still need to push the code to that main repository such that when you do these meetings of planning, development, you know, figuring out, okay, what changes should be made to the functional requirements of the whole product, those kind of things, then the entirety of the code base needs to be available. Because at the end of the day, your code being all right does not ensure that the end product is good. You see? So it is of very vital importance that all of the code that is being written by different units of your project team, right, can be synced into this single repository. Okay, and such that it is always accessible to either all the developers or the end user or client who's paying for it, right? So that is the whole idea of continuous integration in a summarized fashion without going into too much details about it, right? So that is continuous integration, and then continuous delivery is while you build and test this, then once that is done, then that should be able to, by default, be pushed to the application or environment which is responsible for hosting that software and then providing access to the end users. Make sense? So together, when we merge these two processes, that is CI and CD, and we automate the individual specs or the individual parts of this process, then that enters into a service that is known as, in Amazon, called pipeline or code pipeline. Okay, so pipeline automates the process or provides the automated process of CI and CD. Is that clear? Okay, so of course this is supported by individual services, right? You don't get it like the whole thing is not within a single thing, but we can essentially merge it together, right? So again, remember, you are a developer. There are 3 steps essentially to begin with. You make code, you push and commit the code goes to some repository. Now, you should be familiar with Git and GitHub. You should be. At this stage, you should be. If you're not, then this is the most good time to start. Okay. The same thing, the equivalent service for GitHub within the Amazon environment is known as code commit. Okay. So if you're familiar with GitHub, then that same thing is called code commit in Amazon, but Amazon also supports GitHub integration. Okay. But even though you use code commit, you don't have to learn something completely new. Okay, so the concept is still the same because AWS code commit works with Git. So all the commands that you know for Git can be used with code commit, right? So nothing is changing drastically. All right. So once code commit gets it, then you can push it for building and testing to another service called code build. Okay, so that is the environment where you can specify how the code will be built, what kind of parameters will be specified, how will it be tested, what are the test cases, and then you can individually test those different cases, right, within the service. So now, once that is done, the results of testing will be sent to the developer, and the developer might then choose to either, make the changes, revise the code, whatever is needed, okay, and then redo this whole cycle again, right? So that is essentially code integration, but the development or the deployment part of it, the CD part of it, is facilitated by another service that is known as code deploy, right? So the same cycle that we just saw here, when we attach that for code release, okay, that is actually you're sending it to the production environment, okay? So until this point here that we have, this is the developing and testing. Remember we were writing that stack codes which is said develop and production, right? So this is basically the barrier between the developing, testing versus the production environment. So once you release the code, okay, it goes into the production stage, and then you use the service called code deploy to essentially push it to the environment that is going to host the code and then make it available to the end user. So together, when you bring all of these 3 processes, which is code commit, code build, and code deploy, within an automated fashion, that is you integrate that as an automated way, then it falls within this service that is called AWS code pipeline. Is that clear? So pipeline, you don't have to worry about these individual stages. All you need to do is commit the code. Once you commit the code, it will put it in the repository, take it to building and testing, and then deploy it. Now again, remember, as developers, if you want to put a manual check between these phases, you can. If you do not, then everything is automated. All right, and that's the whole power of automation in terms of development. All right? Yes?
Is this usually able to work such that the service has zero downtime? Like
Yes.
the old version is still
Yes.
around, but still
Yes.
runs, right?
Yes. So suddenly you refresh and you see a new version is there. You wouldn't even know the difference. So the application has to be really something like, the change has to be something really like stress inducing for you to actually notice a difference. Otherwise, you won't be noticing any difference. Okay? Alright? So remember, here, the environment can be many different things. It could be an elastic BeanStalk, which is a platform. It could be an EC2 instance. It could be an ASG with load balancers. It could be an S3 bucket, whatever, as long as it can host. So that is something you have to remember, that although in this exercise, upcoming exercise, we're going to do this with the environment being an elastic BeanStalk, that is, the deployment will be pushed into an EBS platform. Make sense? Right? However, you can replace that with whatever you want, as long as that service can essentially host it, host whatever code that you're writing. Clear? Alright. So again, for code pipeline, you can check the case studies. Lululemon is there, 3M is there. And then what we are going to do is basically build this pipeline which uses code commit, which uses elastic BeanStalk, okay? And then the code pipeline is going to deploy, using code deploy, the application into elastic BeanStalk environment, which is hosting a Node.js app which we developed in the previous course. Not previous course, the previous exercise, okay? All right, so let's do it. So make sure you actually need access to the code itself, so you cannot use that sample code that we have. So please, I want you to do is go to this link first. You can terminate the previous thing that is running, okay? You can go ahead and terminate that. So if I go to this link here, this documentation link, which has a lot of sample codes. You can see all the tutorials and sample are there for like different deployment architectures for different technologies, if you're familiar with that, or if your organization chooses to work in any of this. But if you come down to the second section, okay, where it just lists these single links here, you will see the link for Node.js. All right, and I want you to download this zip file. And I want you to unzip this and put this folder as a repository or as a workspace into Visual Studio. Are you using Visual Studio? Any IDE is fine, as long as you have an IDE. Do you have an IDE? Yes, no? Where do you code on your machine? Use that. As long as that is not a notepad, WordPad kind of situation. Okay, so just download this, load this, okay? And the second thing, while you're doing this downloading, I also want you to, how many of you are not familiar with Git? Anybody here? Git? Okay. If Git is not installed, please install Git. So that's the second step that you need to follow through. Alright? Does everybody have Git here? If not, just install it. That's absolutely fine. Just go to Git downloads, and then whatever distribution you're using, Windows, Linux, Mac, whatever it is, just download it. Okay? Alright, so if you have downloaded it, where will I upload it from? So actually, never mind. Okay. So the next thing that we want to do is we want to create a repository in code commit. Okay, if you look at this workflow here, we need to first develop a place where we can push our code. Okay, and then we can essentially create the pipeline using BeanStalk and stuff like that. Right? So if you have downloaded the code, the next step that you want to do is go to this service called code commit. Okay, I'm not doing this here because I don't have access to install all of these stuff. Okay, so you need to talk to me if anybody's stuck. Otherwise, I cannot help you out. So what you want to do is, first, I will just terminate this application. Okay, and it will ask me to write down the name. Okay, and let it do its stuff. And while that is doing, I will go and look for an application called code commit. Okay, so this is essentially the application here. Right? So if you come here, it will open up in repositories. Right? So we want to first create a repository, and that code that you just downloaded, we are going to sync that code as a workspace folder to this code commit. Does everybody understand this process? Yes? No? Yes? Okay. So then create a repository, give it a name. So I can give it like my test repo, whatever. You can give it a description, you can give it some tags. There is a code guru reviewer if you want to add that, but sure, why not? Anyways, just hit create. Now if you hit create, this is what you should be looking at. Does everybody see this screen on your machines? Right? So there are multiple ways of connecting it. As you can see, if you go down, you can create a file here, or you can add a file by uploading a file. Right? You can do it, not the best way. And that's the easiest way to lose a job, probably. So what we are going to be essentially then doing is to set it up with Git. Okay? So the first step is, of course, you need to have Git. That's the first thing. So please make sure that you have Git, otherwise you cannot do this whole thing. Right? So the next thing is, once you try to log into Git, basically you will be running this command on step 3, which is to clone this repository that you just created on your machine, like connect it with your local machine. Do you follow? In code commit first. So do you see this page? Okay, so are you in code commit?
Yes.
So create repository, give it a name, and then move forward. Okay? And then you should see this page where on the top it says success, and then you have these 3 steps. Okay, the first step is to essentially make sure that Git is there on your machine. So if you do not have Git, please download and install Git. Right? If you have Git, then the next thing is we need to create the credentials so that we can clone this repository of Amazon and sync it to our local machine, or sync it basically with Git. Do you follow this? Right? So we need to create this credential. So in order to do so, you need to go to IAM, or Identity and Access Management. So please go to IAM, the service IAM, then click on users, okay, and then click on the user using which you will be logging into this code commit repository, or you will be authenticating. So this is my username, so you will have your username as well. Okay. Then in security credentials, come to the tab of security credentials, and then if you browse down, you should see a section called HTTPS Git credentials for AWS code commit. Does everybody see that? You would be seeing generate credentials here. I have some additional stuff because I've already done it. So if you hit generate credentials, then it will show you a password and stuff like that, and a download option. Yes? Please download and save that somewhere, because you will essentially need that when you run that command to sync Git with this. Clear? Yes? So go to IAM, you're looking for a service, then click on users, then click on the username that shows there. You should have created a username. Then come to the tab called security credentials here. Okay, and then browse down, scroll down, and you should see the Git credentials for code commit. Did everybody download that? Keep it somewhere. Shall we move forward? Okay. So the next thing that you want to do is open a Git bash. So you can either do it with the integrated terminal of Visual Studio Code, if you have Visual Studio Code, or you can open from your services, you can open the Git bash which comes with Git when you install Git. Whatever it is, either open it in VS Code, or you can open it in the regular terminal. So please open a Git bash, then copy this third command, which says here git clone and then the repository name that you just created, and then run it on your Git bash, on your local machine. Okay, so I have done it using this. Can you see this image? Is this visible? Yes, no? So this is my integrated terminal. What I did is I added a folder as a workspace to Visual Studio, and then I opened a Git bash, and then I executed basically this command which is available on code. Once you do that, it will ask you for a username and password. Where you have that? In the file that you just downloaded. Okay? So provide that username and password, and it will create the folder, it will create the repository of code commit as a folder that is synced with Git. Is that clear? So please try that step out, and you should have that. If it's successful, then it should see that it will tell you that you have cloned an empty repository.
I created a repository, but I cannot see like where the repository. From where we can get the link?
Which link?
You have clicked some link, right? Yeah, this particular page.
So the moment you create this repository, it will show you this step under the connection step. So if you see it like this, then it will be, you can create a drop down, and in the HTTPS is where you will get it. If you are going to use SSH, then there are different instructions for SSH as well, if you're using SSH connection. Okay? What are you seeing?
In code commit, repository I have created, but it's not showing.
So for all those who have created the folder, and you can see it on Git, okay, essentially that zip folder that you downloaded, you need to unzip it, get all the code, and then copy paste that into the repository which got created on your local machine. Does everybody follow? So please do that. What have you already? Yes. Close the door. Close the door. So you have not done the IAM one, right? Okay. So please unzip that, get everything there. If you have a basic HTML file, a package.json file, a YAML file, and stuff like that. So copy paste that and then put it inside this repository that got synced with Git. It has the same name as the name that you gave when you created a repository on CodeStar. Is everyone with me? Yes? Alright. Essentially, while you're doing that, open another. Did you all terminate the EBS one? The EBS exercise that we just did? So go back to Elastic BeanStalk, okay? Create a new environment, and the zip file that you downloaded, right? Upload that as code. So go to create environment, choose web server environment, give it a new application name, so we can say something like exercise 2 or something like that, whatever, okay? Environment name will auto-populate, domain leave it blank, platform keep it as managed platform, and then in the platform choose Node.js. With me? Okay. And then instead of using sample application, choose upload your code. Alright? And then go to this choose file option, and then the zip file that you downloaded right now, just upload that zip. Make sense? So, did I download it? I forgot. See, I downloaded the zip file, right? So I'm just going to double click on this and upload this zip file. Do you follow? Yes or no? Okay? So all you need to do after this is just create the environment and let it run in the background, right? The sample code that we used in the first exercise, this is the same code that you just uploaded. The reason why we are doing it a little bit separately is because we want to change this code and then kind of push it for a new deployment. Make sense? Now how many of you are stuck? Anybody needs any assistance? Please raise your hand. All good? Yes? No? Okay. So the next thing that I want you to do is go back to Visual Studio and you need to change the index.html file. So in the index.html file, what we want to do is, everybody saw that hello world page, right, that got created. It had a green color. Do you follow me? Okay. So if you go to the index.html file and come down to this dot text column in the style body, in the style area of the CSS, right? It should be within the style tag. There should be a background dot dash color, which should specify green. It should have a code of green. Just change that to whatever color you want to. It's just a basic change. You don't have to worry about putting red. I did it red. You can give whatever color you want. Just make that change. Save it. Okay? Once you save it, then do the git process. That is git add dot git commit, give it a message, and then git push. Okay? So those are the 3 commands that you need to run once you edit and change. This should directly push the code to code commit. So that empty repository, that warning that you got, should go away. Do you follow? So please try that. And once you do that, if you go back to code commit, and if you refresh the page for code, then here in your test repository, instead of looking at empty repository, it should start showing you stuff. Well, stuff meaning exactly the code which you just edited. Is the process clear? If anybody has any issue, please raise your hand. This is what you should be looking at in your repository, all the codes. If you refresh the page, that is. How many of you have got till this point? Just 3? 4-ish? What about the rest? Talk to me. I cannot help you if you don't talk. So for those who are done, please follow the instructions on the slide right now. Essentially, you will see here on the left menu that even though we are in the service of code commit, okay, these other services for building, deploying, and pipeline, these are very closely knit operations. These are essentially the developer operations, all right? So the next process that we want to do is, since we have synced the code commit repository, which is basically Amazon's version of GitHub, with our local Git, right? Any changes that we make on our local machine, if we push it, it will go to commit. So the immediate stages of building and testing and deployment, we now want to automate that whole thing by creating a pipeline. So the next stage that you want to do is basically go to pipeline, and then click on pipelines, all right, and then create pipeline. So once you create a pipeline, you can give it a name, okay, whatever name you want to do. I'll just give it test pipe, okay. So new service role, you can create it and allow AWS to create a new service role. So let it just create that service role. Everybody remembers IAM roles? Allows services to do certain permission-based operations. So let it do it, okay? in the advanced settings, you can leave the default, okay? You don't have to change those. So now it will ask you where are you getting the code from. Do you follow this question? Where is your code? Code commit, the repository that you are syncing with your local machine, right? But if you drop down the menu, you will see that you have a lot of different options here. You can use GitHub, you can use S3, you can use Bitbucket if ever somebody has used this, okay? This is another GitHub alternative. And then, since we developed code commit, we're going to select code commit. Under the repository name, you will see a repository that you just created, okay? And then in the branch, you will only have the master branch because you guys did not create a separate branch on GitHub. But in an actual environment with developers, right, everybody will be working on their own branches. If not, then something is seriously wrong. Okay? So you should be seeing the master. I did not have Git, I could not commit, right? But you guys should be seeing master. So select master, okay? Keep the default stuff, go next, alright? I cannot even go next, but let's see if we'll just hack it. So now here, you can provide the build, who is going to test the build, alright? So you can use the service code build, or you can use Jenkins, okay? Jenkins is another software that is used for building and testing purposes of different code. So we will be sticking to code build if you ever need to. Here there is no build as such for the code that we are using, alright? There is no parameters, input parameters that is required, and there is no test cases. So I'm going to skip the build stage. Remember, in the pipeline, this is the only optional stage that you can do. So I will skip it. It will ask you to confirm, skip it, and then it will ask you where do you want to deploy this application. So if you go to deployment, you will see that there is again a lot of different options. Which one do we want to use? The elastic beanstalk, exactly. So from here, you are going to basically look for elastic beanstalk. Again, remember there are multiple options that are available. And then choose the region. For me, it is Ohio, wherever you guys are working. Choose that particular region. Choose the application name. Now, know the fact that I just launched an application, okay? Which is, I forgot, I think exercise 2, okay? I'll just make sure. Yeah, exercise 2. So, and then the environment name is going to be exercise 2-env. Alright? So if you're still running that previous exercise EBS application that we used using the sample code, it should be fine because we are using the same code and we made the changes. So it will be able to kind of recognize that it's the same project. Alright? So now if you go next, alright, review everything and then create the pipeline. Okay? So if you create the pipeline, then you should see something like this. So it will show you the source, did not give any kind of build, so it's not showing any build, and then it shows the deployment. So initially, it will say everything is in progress. If you notice the screen cap on my slide right now. Okay? Then, once the code commit has been validated, then it will say that it has succeeded, and then it will recognize that there has been a change, which will be the message that you used to commit using Git will be displayed on code commit. Give it a few moments, okay? It will start showing up. And then once that is done, it will go to deployment, and this is the final screen that you should be expecting. A green light on both the source as well as the deploy. We don't have a build stage. How many of you are still in pace? How many of you are still trying to do it? Is deploying?
Yeah.
Yeah, that's fine. I'm just asking, is there anybody who needs help again? Anyone got through the source validation? You did? Okay. So the next one is basically the deployment. EBS will deploy it again. So if you go back to EBS and click on the link page for EBS, now whatever color you specified, that is what you should be seeing, right? So note here is all you did is commit, because from now onwards, if you do any change to the code and run those 3 commands of git add, git commit, git push, this thing will start acting by itself. So why don't you go ahead, so all you did right now was create the pipeline, right? So as a self-exercise, go back to that index.html file, do another quick change, and run those 3 commands. You will notice that this thing is fired up by itself before you can even go to that page and look at it. Yes?
You have to hit release change for to actually do anything. There's a orange.
Not necessarily.
Okay.
If the device should succeed, then EBS should show the change. Can you go back to EBS and see if you see the change? If you see that, then it is there. Because the next step is essentially, if you see this, right? If this says succeeded in the deployment, then you can simply go back to EBS here. Okay, where am I? Okay, my previous deployment failed or what? No. So here if you see go to environment, if you click on this, then whatever color you changed it to, you should be seeing that. You don't need to press release code. So do you see that? Whatever change you made. Yeah? Then that's fine. So what you can do now is you can go back again to the index.html, make a quick change, run those 3 quick commands, and you should see that code pipeline has fired up their operation. The moment you commit, the moment you git push, it will start doing everything automatically. Again, the validation of the repository, build-in test if you added it, and then deployment. So that kind of automates the whole process of DevOps. Essentially, that's the whole goal of pipeline. Make sense? So your focus then is what? Just the code. You're not paying attention to anything else once you set it up. Yes?
So what is the release change going to actually do?
The release change will happen in the CodeStar. We will automate that process as well in the production environment. Give it a second. That's the next step. Okay? Did everybody understand this whole process of code pipeline? It essentially automates the process of developer operations, which essentially means committing the code, validating it, building and testing, and then deploying it. Okay? Again, remember, this is just one exercise which used Elastic BeanStalk. You can use any available environment that can support your application. That is an important thing. Second thing to keep in mind, we use AWS code commit as our repository. You can use GitHub if you want to use GitHub. The only thing that you have to be aware of if you're using GitHub is whether your code has any compliance issues or not. That is an important thing that people forget, that GitHub, yes, can support everything, but GitHub is also public. Okay? So you have to be very careful if you're working for an organization for whom you're developing something that requires to follow certain privacy regulations, such as health applications and those kind of things. Do not mindlessly just push your code to GitHub. Be careful what you're doing. Okay? This still remains within Amazon's domain. You can have the IAM requirements. Amazon has its own security stuff going on that is trying to protect that repository. GitHub also has it, right? But it's still considered to be more public. So be very wary of where you're pushing your code. That's a very sensitive issue that you don't want to be responsible for. Okay? And even if you are, solve it. That's the thing. Okay? Mistakes can always happen. It's not a career-ending thing, though. Anyways, so the next thing that we want to do is basically clean up our canvas. So the first thing is delete your Elastic BeanStalk application. Okay? So you need to go to this. This is what you will be looking at. From Actions, come down here and hit Terminate Environment. and then it will ask you to write the name of your environment. So just copy that, paste it, terminate it, okay, and let it do its stuff. And then you need to come to your pipelines services. So you need to go to either code commit or find code pipeline, whatever it is that you're doing. And then you need to select your pipeline, and here you can see there is an option called delete pipeline. So select the pipeline and then hit delete pipeline. And I think it will ask you to write delete me or something like that. So just do that, and that will clear the pipeline. And if you want to delete the repository that you just created, then you need to go to source. From source, you need to click on repository on the left menu, okay? Then here, you need to select the repository and then go delete repository and then just type delete, okay? Right, and that should have cleared the repository. But there is also some, remnants, yes, of this whole thing, remember? So that's always going to be in S3. You can do that later, okay, because we need to do one more thing that will create a lot of S3 stuff, right? So that is our last and final automation operation that is known as AWS CodeStar. Now what is the difference? What does CodeStar do additionally? That is something that we have to learn, right? So again, as defined by AWS, this is not a platform, this is a development service in itself that kind of manages everything, all right? So it provides tools to develop, build, deploy applications, okay? So what's the difference of this from pipeline? Can anybody intuitively kind of reason? How does this vary? So as defined by AWS, CodeStar provides you tools to develop, build, deploy applications on AWS. So if somebody asks you, how is this different from pipeline? How would you rationalize this? Yes?
I think pipeline doesn't really help you develop necessarily, does it?
Yes.
It doesn't build.
The develop part is not there. So this is also going to provide you integration with your IDE, your CLI services. If you want to add Visual Studio, you can use what is known as Amazon's IDE, which is Cloud9, okay, and those kind of stuff. So it gives you a little bit extra than what Code Pipeline was doing, because Code Pipeline was focused on DevOps, right? That is what kind of operations a developer is going to do, that is write code, commit, build and test and deploy, right? But this also gives you development tools in addition to that process of automation of DevOps, okay? So essentially, this is how the process works. So you are only responsible now. So if you remember, there is a trend. There is a trend in everything that you learn, okay? And the trend is like there are foundational concepts, and then you build on top of that to make your life more easier. Initially, you were just working with EC2. Then you learned about automatic scaling groups. Then you learned about ELBs. When you learned about them, you did not have to launch EC2 instances separately. Then you learned about databases. But then you learned about these environments which can launch or automate the process of launching these environments. So now you don't have to deal with anything, right? So now you don't have to deal with cloud formation, code commit, code build, deployment. You will deal with this interface called CodeStar, which will interact with formation, commit, build and deploy for you. And that will provision two things. First, infrastructure. Second, application environment. So now you're moving more and more up the ladder and making things more granular or broader, right? But you need to know what is happening in the underlying things. Otherwise, you won't be able to interact if something goes wrong, right? So essentially, the exercise that we're going to do with CodeStar is basically to build a project, okay, that will provide us with an environment which will provision three infrastructures. One, S3. Second, Lambda functions, which is kind of like a premonitions to what is going to come in the next lectures. And then the other one is known as a API gateway, not an endpoint, but a gateway. Okay? So these are essentially the three infrastructure and services that will be launched. Okay? So this is essentially going to be a web server, all right? But it is not going to be launched on an instance. That is the main difference, all right? So this is actually called a serverless architecture, all right? So when you run a server, right, it is running on a machine, on an instance, and it is responding to any request based on the endpoint or the URL that it provides us. Okay, but here when we are launching what is known as a serverless architecture, then it is going to fire what are known as functions based on certain events as it happens. So you don't have to continuously listen to something. You see what I'm saying? Right? As a server, you are always monitoring what is happening on all those endpoints that you have exposed, if you have a REST API, let's say. Okay? But when you have a serverless architecture, essentially, which is in Amazon implemented using Lambda functions, you are basically creating function which will be triggered on certain events. And that will change the web page on the front end, because that function is going to basically deploy those web pages. Right? So Lambda functions are essentially function as a service. You see, so all you're doing is writing functions which is going to fire up certain operation and update the web pages. Okay, so more on Lambda functions when we actually talk about Lambda functions. But now, please remember that our whole goal right now is to create a pipeline with CloudFormation, launch infrastructure as a service for S3, run a Lambda function, and then create an API gateway, okay, for a Node.js web application. All right. So in order to do that, please find the service called CodeStar from your console. So I think this is deleted, right? And I think there was one more thing that was being deleted. Okay, so this is gone. I don't need IAM. Just give me 1 second. I need to get out of here. All right, so I'm looking for CodeStar. All right, so create a project. Okay, so now here, the first thing you see is templates. All right, so if you launch the templates, you can see that there is a lot of different services that you can choose for Amazon itself. Remember, it's for infrastructure provisioning as well as application provisioning. Okay, so you can choose one of these, or you can choose one of these, and you can choose one of the different programming languages that are available. In addition to that, if you look at some of the more popular options that are available, then you can see that here we have our Node.js application type, which is going to be a web application. It's going to be serverless by using the Amazon Lambda, right? So if you look at Python, if you're familiar with Python, right? So then you can use Python and Lambda. If you want to host a static website, you will see that that is no longer serverless, okay? Because serverless requires certain events to be triggered, functions triggered based on events. If something is static, then there is no change. If there is no change, you cannot react. Do you follow? So that is why you actually need a constant listener if you're hosting a static website. And as a result of that, you can see that here you're using EC2 rather than a serverless architecture with Lambda. Does everybody follow? Okay. And then you have Express here as well. If you're familiar with Express, then you can use Express as well. So we're going to select Node.js because we had that sample application running already. So we're going to continue down that line. If you want to use anything else, you can do it as well. You also have the option of Flask if somebody is familiar with Flask. Go next. Here, the next thing that will be asked is your project name. So I can say here CodeStar example. You can give it a name. It will create a project ID. Just leave it as such. Okay. Please give better names than what I am doing. Essentially, when you're doing this properly. Okay. Then it will ask for a repository. Again, remember, we are not creating this repository manually. We're just specifying where do we want it. This service will do it for us. Okay. So more higher level of automations. So I'm going to stick to code commit because that's just what we learn. If you want to do GitHub, you can do it, but then you have to sync the GitHub link and stuff like that. So just remain within the housing stuff. Give it a name, okay, for the repository. So it is just using my project name. So if you want to change it, you can change it. And once done, go next, okay, and then just hit create project. All right, so this will take some time, and the way we want to monitor this is we want to open a separate console. And we want to look for CloudFormation. Because the first thing that will happen is this will be executed as a stack, right? And if you want to monitor what is happening in your stacks, then you are essentially looking for the operations or the events in the CloudFormation operation. So give it some time, let it start doing its stuff. Let's wait for it to get to the CloudFormation part. This is going to take some time. Okay, so let's wait it out and let's see if there is anything else to discuss. Okay, so a few things to note while you're waiting for your provisioning to take place. These are some of the things that you need to keep in mind. Okay, so pay close attention to what can be done once the project is provisioned. All right. So the first thing is this gives you IDE support. Okay, and you have two different options. One, you can use AWS Cloud9, which is the IDE provided by Amazon. All right. If that is not what you want to use, and many developers choose to go with Visual Studio. Okay, that's one of the most popular right now. Okay, so then you can integrate locally by installing the Amazon extensions of Visual Studio and then connect your Visual Studio with this CodeStar project. Do you follow? Okay. The other option is, if you do launch Cloud9, you will have to launch an EC2 instance. So you have to pick and choose like how you're going to work with the IDE essentially. On your local machine, or do you want to SSH into it and then connect to the IDE, or you want to use browser connectivity and then log into your instance and then work using the IDE there. Okay. There is also options where you can add team members to this project, and they can all be working on their pieces of code at the same time. Okay, and everything can be synced together. So that's like simultaneous people working at the same time and you being responsible for adding them to the project. As a result of that, since this is a project management thing, okay, if you add more users, you have the option of adding Jira. Have you heard of this tool from Atlassian? Jira, it's for project management tool. You can decide on deadlines, who is doing what, assign tasks, and monitor your progress, right? So there is also an option for integrating essentially Jira with your CodeStar project. Okay, once you start adding users, all right? So once that is done, and then you can check the codes from the repository tab, all of the codes that will be developed, because there is a bunch of code that will be deployed for this. One is for the web server, one is for your Lambda function, okay, and then if there is any other code that you're writing, that will always be present in your code commit repository. Okay, any code that you're trying to access will be present in code commit if you use code commit. If not, GitHub. Is that clear? All right. And then finally, you can individually open the services that is being provisioned. So for this example, we are using S3, we are using Lambda, and we are using API Gateway. These are the names of services. Okay. So individually in AWS console, you can search these services and open them up to see what changes has been done due to the provisioning of this CodeStar project as well. Okay, if you want to take a look at it individually as to what is happening, right? So the next thing that you want to do, I don't know, has it been provisioned for anybody? The CodeStar project, you can check it. Okay, so here I'm looking at this from CloudFormation. Okay, in CloudFormation I'm essentially looking at events, so it's still not done. It just gone through one phase. It still needs to do. Okay, so it's still going to take some time. You can go to CloudFormation and you can go to events. If you can click on stacks, it will show you the stack that is being created. Two stacks will be created, one for the infrastructure, one for the application deployment. So right now for me, I'm just looking at one particular stack. Okay, once this comes to 2, then I know that this is done. All right, so be patient. This is not yet done. Okay, so quickly to just walk you through what I was talking about. If you look at the screen here on the dashboard, on the left hand side you see Teams. Okay, so if you go to Teams, then you can create a user profile for yourself and you can add more people to it. Is that clear? In projects, if you look at this last tab called issues, you can see that's where you can integrate Jira from. Okay, if you go to repository, and if you click on this repository name that you have here, okay, then you can see all the code that is there. So right now these codes have already been automatically created for me depending on the type of template that I selected. It also created a README file. You can edit the README file whenever you want. So from here, in that self exercise, what I was trying to tell you is you can go to public folder, you can click on index.html, and you can edit in browser. So you see development support that we were talking about, right? I don't have to download this, put it in my Visual Studio, sync it with Git, and then work on it, right? So I can click on edit here, and I can make certain changes. Okay, later on. First you need to look at the hello world. Once you have made the changes, you need to write who made the changes, give it a commit message, and then commit the change. Just like you did with Git. Okay? Alright, so discard. I don't want to make any changes for now. Go back to my DevTools. Okay, repository, build, and then right. So okay, where are we with our? Okay, so you should be seeing two stacks now. If you have CloudFormation open, yes. So you note. The first stack that I see on my screen, at least, this is for the infrastructure. So if you click on that, and if you look at the events, right, then you should start seeing the different things that has been done, right? So for example, a serverless REST API has been created here, okay, and then you have a hello world that is being deployed, and all those different types, right? And if you go to the next stack, which is just for the CodeStar example, you can see the different things that has been provisioned here. So for example, the code commit repository was created, an S3 bucket was created, a publicly accessible website S3 bucket was there, okay, and then a lot of other things are happening, so you can take a look at that, right? So if you come back to here, on the top right you should see a button called View Application. So if you click on View Application, then this is the hello world page that you should be looking at. Okay, and that's what the index.html file has. Got this? Yes? So basically a few clicks and now you can start coding. And everything is running in the background. Remember the pipeline and everything, that's all running, by the way. So if you look at CodeStar here, there is an option of or tab of pipeline. So the pipeline is already active. So everything that you did in the pipeline is already active here. So the moment you push anything, this will already build, deploy, and then release it in the service that you selected. Okay, or the gateway endpoints that you selected. So the other thing that I was talking about is now you can individually, everybody took a look at CloudFormation, so you can go to S3 now, and then you can take just an observation on, you can see that for me it has created 3 different CodeStar buckets, okay, one for the pipeline, one for the application, and I think one for the infrastructure, okay, and then there is another bucket for which it was for the elastic beanstalk exercise that we did, right? Similarly, you can go to Lambda, and you should be seeing a Lambda code here, okay, a Lambda function for hello world, because we have not actually implemented any functionalities, but you can start editing from here, right? And the final thing that we did in terms of infrastructure was the API gateway, okay? So here for the CodeStar application, how it is accessing that API infrastructure is basically a REST operation, so you can essentially add more actions here. We have a GET request here, you can add put, post, whatever it is that you want to do. You can change it here or you can change it from the code itself, right? And you can manage it from these different operations. Alright, questions? So if you look at the last self-exercise, I want you to go to the repository, okay, go to the public folder, you should find the index file that is essentially being shown to the users, open it in the browser, click on edit, find something that can be seen by the client. Let's say, for example, this message, congratulations, you just created. Add a few lines here so that you can notice the change. Give your name, email address, a commit message, commit it, and then go to pipeline and see how pipeline has started executing the changes immediately. Okay? And then the moment it is done, it will release it. So please try that. That's the last thing that I would like you to try, and then you are free to go. Once you have committed the changes, come back to CodeStar and then look at the pipeline tab, and you should start seeing the changes here. Okay, if you're done, then you're free to sign off. Please make sure that you clear your canvas before you go, and that requires you to delete your CodeStar project and make sure that everything is deleted, and then go to S3 and delete the buckets. Okay? Yes?
What's the easiest way in general to just quickly glance that everything is deleted?
There is, unfortunately, no. The best way is to keep an eye out for CloudFormation, because CloudFormation is going to unroll everything, so you can monitor in the events if everything that has been provisioned is being removed or not. But as you can see that there are some services which cannot be unrolled by CloudFormation, for example in S3 buckets specifically. So my best suggestion here would be to do the supervision from CloudFormation, but just do a last check on the individual services that has been deployed if they are going to incur any costs. Or what you can do, this is another way, you can actually create alarms when a service is terminated using SNS, right? So if you do that, once you delete everything, it should send you a notification for everything that is being removed. So that could be one way, yes.
Isn't there a page, I'm having trouble getting back to it now, but isn't there a page you can go to that says like however many instances running and however many functions and so forth, with some overview?
Oh, you mean that everything that it shows in the very first page, right?
Yeah, I don't remember getting back to that.
I think it's in EC2, not in EC2. It is actually in VPC. Check VPC. VPC should show everything that is going on within your virtual private cloud. How many subnets, how many instances, how many RDS, everything should be shown there. Because everything that you, remember this is a good point, everything that you deploy happens within your VPC. So as a collective representation of what is happening in terms of your resource provisioning, go to the service VPC and you should see everything there. Okay? But again, please make sure that everything gets deleted. Otherwise, they're going to, in the back end, keep on incurring cost. Okay, go back. Okay, so we're going to stop the